So today we are going to discuss about the high availability, fault tolerance, and data protection techniques that are available in vSphere. Okay. So in this chapter we discuss about the high availability and how to enable the high availability on your vSphere. So basically, the high availability, fault tolerance are the features of your vCenter. It's not the feature of ESXi, it's the feature of your vCenter server. Okay.
Okay.
So for the high availability, we create the clusters of ESXi host and we enable the high availability. If any host goes down, so virtual machines will start on another host. So basically, most of the organizations relies on the computer-based services like mail services, database, web services, and if failure in any of these services can impact their productivity, their revenue, their quality of services. So we need to configure the high availability. So your service will be continuous if you are facing any like kind of hardware issue or another issue, application issue. So in this module, we have total 5 lessons. So in first lesson, we introduce the high availability, about what is the high availability, and in the second lesson, we discuss about the architecture of high availability. Third lesson is about to configure the high availability. Then we discuss about the fault tolerance and the replication. So let us start with the introduction of high availability. So in this lesson, we describe the options that you can configure to make your vSphere environment highly available, and discuss the response of vSphere HA when a ESXi host, machines, or application goes fail. So basically, you have different components to provide the protections at different layers. So vSphere enable you to reduce your planned downtime, prevent the unplanned downtime, and recover rapidly from the outage. So there are some components like the storage or network. For network failure, we use NIC teaming or storage multipathing. For server failure, we use like vSphere high availability, fault tolerance, vSphere vMotions or DRS. For storage failure, we use vSphere storage vMotion or storage DRS. You can also use the vSphere application and third-party backup solutions. And for the sites, we use the site recovery managers. So basically, vSphere HA provide the base level of protections for your virtual machines by restarting your virtual machines in event of the host failure. So when your host goes down, the machines will restart on another host that are the part of your HA cluster. And vSphere fault tolerance provide a higher level of availability. So it's allow the users to protect any virtual machine from the failure with no loss of data. So basically, when you use the HA in a vSphere HA, your protected machine will restart on another host. So you lose your runtime data. But if you are using the fault tolerance, it's create a secondary machine on another host server. So if your first machine goes down or your host goes down, secondary machine start to provide the response. Okay, so the fault tolerance is like active passives. So there are some recommendations for vCenter server availability. So make the vCenter and the components that relies on high availability. And there are some major components like vCenter database. So create a cluster of database, set up a native backup and restore for your vCenter database. For the authentication, like your vCenter single sign-on or Active Directory, set up with multiple redundant servers. So if your one vCenter server goes down, another server can provide the response at that time. And methods for making the vCenter availability, you can use the vSphere HA, vCenter server high availability to protect your vCenter server virtual machines. So there are some scenarios like vSphere protect some failures like it's protect against the ESXi host failure, protect against the data accessibility failure, data store accessibility failure, protect against the application failure, and protect the VM against the network isolation. So the first scenario is about the host failure. So in a vSphere HA, we create a cluster of more than two hosts. So if your one host goes down, the running machine of that host will be restart to another host. So for that you need a shared data store between them. Okay. The second scenario about the guest operating system failure. So if your guest operating system goes failure, that machine will be restart on the same host. Okay. But to implement this failure scenario, you need to install the VMware tool inside that virtual machine. Okay, because the VMware tool provides the heartbeat between your guest operating system and vSphere HA. Third scenario about the application failure. So when the application fail, vSphere HA restart the impacted machine on the same host and VM component protection required for the VMware tool. So there is a VM component protection required. So you need to install the VMware tool inside your virtual machine to protect against the application failure. So vSphere provide the host, VM, and application failures, protection against those failures, and against the data accessibility failure. If a VM component protection is enabled, VMCP, vSphere actually can detect the data store accessibility failure. If you do not enable, you cannot protect your machines from the data accessibility failure. So you need to enable this feature. So it can detect the data accessibility failure and provide the automatic recovery from affected virtual machine. So you can determine the response that the vSphere HA make to such failures, ranging from the creation of event alarms or restarting your VMs on another host. So you can like set which kind of the actions you want to perform when your data accessibility failure goes happen. So there are two type of loss when data accessibility failure happen. One is the permanent device loss (PDL). So it's unrecoverable loss for accessibility occur when the storage device report the data store is no longer accessible by the host. And response can either issue an event or power off or restart your VM to another host. The second loss is all path down. So it's a APT. It's recoverable and represent and transistor unknown accessibility loss. Response can either issue an event, power off and restart your VMs, and constructively restart policies, power off and restart VM aggressive restart policy. So you can implement those policies for that one. Against the network isolation. So if your host is unable to communicate on the network, so in this case, that this failure is known as the network isolation. Your host is isolated from the network. So vSphere HA restart the VMs of their host become isolated on the management or vSAN network. So host network isolation occurs when a host is still running, but it cannot no longer observe the traffic from vSphere HA agent on the management network. So vSphere HA try to ping the cluster isolation address. A network isolation address is an IP address that is pinged to determine whether host is isolated from the network. So you can manually set any specific IP for isolation address. If host is unable to ping with isolation address, the host declare that it's isolated from the network, and this protection is provided even if the network has become party node. So in this case, your VM will be restarted on another host. Okay. So basically in the vSphere scenario, vSphere HA scenario, we use a separate network for HA traffic, like heartbeat traffic. So for the heartbeat traffic, you can use you can use your management network. You can implement a alternative heartbeat network, or it can also be used by the vSAN network as a heartbeat network. So later we discuss how to create a heartbeat network and which kind of network can be used to transmit the heartbeats. So importance of redundant heartbeat network. So if you have a single heartbeat network and some of reason your network goes down, so there's a misunderstanding between your host because they are unable to communicate with each other and they declare as a isolation. Okay, so try to implement the redundant heartbeat networks. So basically so they are sent between the master host and slave host. So the heartbeats are sent by the master host to the slave host, and slave host provide the response of that heartbeat. So they are used to determine whether a master host or slave host has failed. So they are sent over the heartbeat network. So redundant heartbeat network ensure that reliable failure detection and minimize the chance of host isolation scenarios. So you can implement the heartbeat networks by using a VM kernel port that is marked as management network, or you can use a VM kernel port that is marked as vSAN traffic when vSAN is in your network. Okay. So for the redundancy, you can like attach multiple NIC cards on your switch, or you can create two separate networks on separate switch to create the redundant heartbeat networks. Now let's discuss about the architecture of your HA. So in this lesson, we describe the your heartbeat mechanisms that used by HA, identify and discuss the other failure scenarios, and recognize your vSphere HA design considerations. So it's important. So here we have a scenario in which we have three host servers, three data stores that are connected with each others, and this is your management network. This is your management network that are common between them. Okay. So vSphere HA, when you enable your vSphere HA, a fault domain manager service start on all host servers that are the member of that cluster. Okay. And after FDM agent have started, the cluster hosts are set to be in the fault domain. So and the host a host cannot participate in multiple fault domains. It can be it only be member of a single fault domain. And if any host in maintenance mode or in standby mode or in disconnected from, you can say it's standalone, or in disconnected from the vSAN, these type of the host cannot be the member of your fault domain manager. Okay, FDM manager. And a host can be only in only one fault domain at a time. And that fault domain is managed by the master host. So in your cluster, you have a single master and remaining host will be the slave host. So that fault domain managed by the master host, and other hosts are the called as slave host, and the FDM agents on the slave host all communicate with the FDM on the master host. So all slave host FDM agent will communicate with the master host FDM agent. And after successfully starting the FDM agent, a process begins between them to choose which one is the master. which host will be the master. So it's an election process that done within the 15 seconds. And to choose the master, we have some criteria like which host has the maximum number of data stored be that become a master. If in scenarios you have the multiple hosts, they have the same number of the data store. In this case, the host that have maximum number of managed object that will be become a master. Okay, so the system that can access the greater than number of the data store is elected as a master if more than one cluster host see the same number of the data store. Election process determine the master by using the host managed objects. So which host use the maximum number of managed object can be selected as a master. Okay, and this process done in within the 15 seconds. Okay, and there are some scenarios where your master goes fail, like master is placed in maintenance mode, master is placed in standby mode, or when you reconfigure your HA. Okay, and the slave host cannot communicate with master due to the network problems, or if your master not be able to communicate with your host servers. So these are some scenarios when your master goes fail. So at the time of the master failure, the election process is begin again, and the remaining host choose their masters based on the same criteria, based on the maximum data store or manage objects. Now here is the architecture of your master host send a heartbeat to all the slave host, and slave host provide the response of that heartbeat to master host. And this heartbeat done over your heartbeat network. You can say over your management network or your vSAN network. And this heartbeat is sent at within a predefined time. Okay. In case of your heartbeat network is not working, then your vSphere actually use your data stores to detect the heartbeat. So basically data store are used as a backup communication channel to detect the virtual machine and host heartbeats. And basically the data store beats is used to detect the region of why the master, why the slave host not communicating. So there are some failure scenarios like slave host failure, master host failure, or network failure, like you can see the host isolation. And VMPC enable vSphere can detect and respond for the storage failure. And there are some type of the data accessibility failure, APD, all path dead or permanent data loss, device loss. So first case when when a slave host goes failed. So when a slave host does not respond to the network heartbeat issued by the master vSphere try to identify the regions. Okay. So to find out the regions, master host use the data store heartbeats. In case of the master failure, when the master host placed in maintenance mode or crash, the slave host detect that the master host is no longer issue the heartbeats. So at that time, they begin a election process and choose their master. Then isolation. If a host not receiving any heartbeat or observing any election traffic on the management network and cannot ping its default gateway, host is isolated. So first of all, hosts try to communicate with their isolation address, their default gateway. If it's not able to communicate, then the host will declare that I am isolated, and all the powered on virtual machines will move, so restart on another host. So there are some design considerations like implement the redundant heartbeat network, implement the redundant isolation address. If your host isolation event do occur, good design enable the vSphere HA to determine whether the isolation host is still alive. And VM network should be physically separate from your heartbeat network, and implement the data store so that they are separated from the management network by using one or more of or both of the following approach like fiber channel or the fiber optics, or physical separating by your IP storage network from your management network. So separate your management network and your storage network. In case of virtual machine storage failure, so with an increasing number of the virtual machine and data stored on each host, storage connectivity problem have high cost but are infrequent. So connectivity problem due to a network or switch failure, array misconfiguration, power outage. So storage connectivity problem affect your virtual machine's availability. So virtual machine on effective host are difficult to manage. Application with attached disk crashed, and VMCP is not supported with vSphere. So about the VMCP protects against the storage failure on your virtual machine. So VMCP run on a cluster base, vSphere HA. VMCP offer the application availability and remediations, and VMCP can detect and respond to storage failure. So third lesson is about to configure the vSphere HA. So first of all, we recognize the recommendations for creating and using the vSphere HA cluster and configure the HA cluster. So a cluster is used in vSphere to share the ESXi host, or you can say share the physical resource between a group of ESXi hosts, and vCenter server manage your cluster resource as a single pool of the resource. So basically, when you create a cluster, all ESXi hosts that you add on this cluster, the resource of these ESXi hosts will be combined, and these resources are managed by the cluster. And features such as vSphere HA, DRS, or vSAN can be enabled on a cluster. So in this lab, we create a cluster and we enable on that cluster is high availability. So there are some prerequisites like first of all, you need a essential plus kit or a standard edition. A cluster can contain between you need at least minimum 2 ESXi hosts, and you can add maximum 64 ESXi hosts in a cluster. All hosts must be configured with a static IP address. If you are using the DHCP, then reserve the IP address on your DHCP server. All hosts must have at least one management network common. And for the virtual machine monitoring to work, VMware tool must be installed in every virtual machines. And only vSphere HA cluster that contain the 6.x host, means you are using the ESXi 6.0 or later, you can enable the VMCP on that cluster. If your host is less than 6.x, then you cannot enable the VMCP. So to configure the vSphere HA settings, you can enable the monitoring, you can enable the host failure response. Okay, failure response, like what you do when your host goes fail, like that. You can enable the machine monitoring, you want to allow the machine monitoring or not, you want to allow the machine and application monitoring on or not. So you can enable on your cluster. You can select your heartbeat data store. So which data store you want to use as a heartbeat data store. You can implement your admission control to distribute your resources between a cluster, and you can reserve your resources for failover purpose with the help of admission control. So basically, admission control it ensure the both that sufficient resource available in a cluster to provide the failover protection and the virtual machine resource reservations are respected. So there is different scenarios in your admission control to calculate the resource. Okay, how much resource you want to reserve for the failover. So you can implement based on the percentage or based on the slot size. Okay, so the slot size is the maximum amount of reservation of a virtual machine. Okay, let's suppose you have 10 virtual machine. Out of the 10 machine, you one machine using the reservation, and reservation is 512 MB, sorry, 512 gigahertz. So your slot size will be 512 gigahertz. Okay, if any machine is more than that, so then that machine will use multiple slots. Okay, so if you look in this scenario, there are three hosts with 9 gigahertz and 6 gigahertz, and 9 GB, 6 GB, 6 GB memory, and all that you are running those five virtual machines. Some two virtual machines using the 2 gigahertz, and three virtual machines using the 1 gigahertz. And here is the use RAM. And let's suppose we fix the slot size. So our slots, let's suppose our slot size is 2 gigahertz for CPU and 2 GB for memory. So if we look on our first host, how many slots we can configure? So our slot size is 9, and the capacity of this host is, sorry, slot size is 2 gigahertz, and the capacity of first host is 9. So if we divide the 9 by 2, so it's approx 4. So 4 slot on your ESXi 1, like that 3 slot on your ESXi 2, and 3 slot on your ESXi 3. And if you check on this machine require one slot to execute. This machine also require the one slot to execute. And this machine also use one slot. The resolution of this virtual machine is 1 gigahertz, but our slot size is 2 gigahertz. So a machine use at least one slot. Doesn't matter what is your size. But if the resolution is more than the slot size, then a virtual machine can use more than one slot. Okay. You can perform the degradation VM tolerance. In the admission control, you can also implement this performance degradations VM tolerance. To provide the failover, you can allow to degrade your virtual machine performance to provide the ratios of failover machines. And there are other settings like you can add your isolation address and isolation delay in seconds. vSphere HA orchestrated restart. So orchestrated restart in the vSphere HA enable 5 tier of restart the VMs and VM dependencies. So you can create a 5 tier hierarchy of VM and VM dependencies. Let's suppose you have a scenario like you first of all you want to start your database, then you want to start your Active Directory, then you want to start your file server. So this is a scenario. So you can create a tier, 3 tier. So this is a 3 tier architecture. So like that, we first support the 5 tier architecture. So choose from among of the following conditions that must be met before a VM considered ready. Like VM has the resource secure. So required resource for that VM is available. Then VM is powered on. Then tool is installed and heartbeat is detected. The VMware tool application heartbeat is detected, and optionally you can configure a delay when a certain condition is met. And the priority tier VM can be grouped into the tiers indicating that their startup priority. So all VMs in the priority tier receive their resource first and powered on. Only when all the VMs in tier 1 have met their defined restart condition does vSphere HA continue to start the VMs in second priority tier. Like that it's done. Okay, so you can like set the priority. So there is 5 type of priority. So you can set your priority like low priority, so lowest, low, medium, high, and highest. So medium is the default priority. So you can choose, you can assign your VMs according to those priorities. So when the like failover done or when you start your machines, it's happens according to that priority criteria. So VM dependency in Worcester restart. So VM can dependent only on the other VMs of the same or higher priority. So only direct dependencies are supported. So to VM dependency is a hard rule. Creating the cyclic dependency cause the VMs restart to fail. So the vSphere 6.5 and later the vSphere HA restart the VMs only from a failed host. Configure the infinity rule to keep the VMs on the same host if necessary. For the network isolation and maintenance, you can so if you are going to like host maintenance or network maintenance, stop the host monitoring. Otherwise, it start the failover when you start the maintenance on your host. So if you are going to start the maintenance window, first of all, disable the host monitoring. Host cluster reservations, so you can analyze the reservations on your VMs for CPU reservations or memory reservations. Monitor the cluster status. You can check your cluster status, who is the masters, how many hosts connected with your masters, like that. Okay, so here we have a lab. So in this lab, we create a cluster, add our ESXi host in this cluster, test the vSphere HA functionality, view the vSphere HA cluster resource use, and manage the vSphere HA slot size, and configure the HA cluster with strict admission controls. So let's go to our lab. So first of all, I'm going to log in on our vSphere web client. Okay. Give me a minute. Okay. Now I'm going to right click on select your host and cluster, right click on your data center and new cluster. Okay.
Okay.
And the name of our cluster will be as a compute one. So I'm going to again right click, new cluster. Okay. Then we are going to enable the vSphere HA. So turn on HA and leave other settings as a default. Okay. So the VM monitoring is disabled by default, admission control is enabled, host monitoring is enabled by default. Okay. So here is our cluster. Now we are going to add our ESXi host on this in this cluster. So you can simply drag and drop. What is the warning on this host? Okay. I'm just simply drag and drop. Yes, I want to move. So look there, configure the vSphere HA cluster. Similarly, I'm going to add our second ESXi host.
Can I ask a question?
Yeah.
Because concerning creating a new cluster, because I thought that in the beginning we said when maybe talking about the data center, there was two XSO under it. So if
Yeah.
I create maybe I do any configuration concerning the data center, automatically it affects everything under the data center.
Yeah. Basically, data center is just an entity.
Yeah. So
Data center.
if I do any configuration under the data set, it affects the SISOs 1 and 2 automatically.
No, no. It will not conflict.
Not conflict, affect.
Yeah, of course. If you are going to make the change on your data center, like if you're deleting a virtual machine inside the data center, so basically that virtual machine is running on a ESXi host. Data
Yeah,
center is
that's what
just a object that are containing your host and your virtual machines.
yeah, because right now the SA compute one is
Yeah,
also just an object that contains the XI host.
yeah.
Because my
Basically,
part
as a
is I
compute.
don't understand. I don't understand why we created a new cluster whereby we already have the XI host under the data center. That's
Yeah,
my point.
yeah. Look there. The data center and the cluster are two different things. A data center is just an entity where you list your objects.
Object. Yeah.
Okay, and the cluster is your object where you can assign your host powers. Okay, so if you look there,
Okay.
you can when you let's suppose you are going to create a virtual machine. Okay, so do
Yes.
not need to select ESXi1, ESXi1, ESXi2. You simply select your cluster name. So it automatically places that virtual machine on the best suitable host.
Okay.
Okay, so later we configure this cluster properly. So in this class, we just configure the HA, high availability. If a host goes down, the machines automatically like start on another host. Okay.
Okay.
Okay. So when we add our host in the cluster, we got some warnings. What is the warning? The host currently has no redundant network. If we look here in the VM kernel adapter, we have a single management network. The management network is used as a remotion, and if you look here the inside the management service, a single network is enabled with management.
Yeah.
Okay, so we need to implement a high availability. So sorry, network heartbeat network redundancy. So we configure it later. Okay. So after configuring the cluster, let's check what is the power of this cluster. So look there. The CPU capacity of this cluster is 16.7 gigahertz, and the
Oh.
memory capacity is 16. Basically, the resource of ESXi1 and ESXi2 is combined here. Okay.
Yeah.
Actually, this is the capacity of all the hosts inside this cluster. Okay.
Okay. Okay.
If you check the VM, so you can find all the VMs here. Okay.
Okay.
So here is your complete summary about your cluster, like cluster resources. Let me refresh this one. So let's check who is the master. So I'm going to just expand this vSphere HA availability. So the cluster is disabled, this. Okay. There is no detailed information. So I'm going to monitor and select vSphere HA, select summary, and find who is the master. Who is the master of this cluster is ESXi1.
Yes, it's our. Yeah.
Host connected to the master, one host is connected to the master means you have a single slave host. One basically in the cluster we have two hosts, one is the master, one is the slave host. Okay. Host not connected to the master 0. vSphere HA agent not reachable 0. vSphere HA agent configure error 0. So you can find all the configuration here. Okay.
Okay.
You can find that your cluster capacity. So look there, the failover capacity means the 50% of the capacity will be reserved for the failover. Okay.
Okay.
So you can use 8 GB memory is reserved for the failover purpose. So you cannot use this memory. This memory will be used when one of host goes fail. Similarly, 50% of CPU capacity reserved for the failover. Okay. How many machines is protected? 0. We have 3 machines, but only uh, but 0 machines is protected with HA. Why? Because there is no power on virtual machines. If I'm going to power on that Windows 10 2, it become protected. Now it's unprotected now because it is starting. After a successful start, it will be become the protected. Now look there. Now it's protected.
Yeah.
So on which host this machine is running? On ESXi 1. So if your ESXi 1 goes down, this virtual machine automatically restart on your second host. Okay.
Okay.
Heartbeats. So host mounted select. So there is no database is data store is selected for the heartbeats. Okay. But here you can find two because these are the shared data store. So these are automatically selected as a heartbeat data store. Okay.
Mm.
You can also in the configuration, you can also configure your vSphere high availability here like that. Okay. Heartbeat data store. So use the data store from the list and complement automatically if need. Okay. So it's selected automatically. Here is the failover and response. So if your host goes failover, your machines will be restart on another host. Okay. Response for the host isolation none. You can also select here. Shut down or restart the VM, power off restart the VMs. Okay.
Okay.
Now we are going to configure the redundant network. Okay. So select your ESXi host, go to configure VM kernel adapter, and we are going to mark the vMotion network as management network as well. So right click on your vMotion network, or you can just select or click on that pencil icon, the edit. So is mark as a motion. I am going to mark as management also. Okay. So this network also used for the heartbeat network. Do the same thing on your another host. Okay. So look that you have two networks for the management purpose. Means you have two management network. Now we have the redundancy of management networks. If we check the cluster, monitor, issue, triggered alarms. So now there is no alarm on the host, monitor, issue. It is still showing this host is currently management network. So we are going to manually reset to green, or you can supersede. Yes. Okay.
Okay.
Now look there. That warning was removed. Okay.
Mm.
Now I'm going to test the functionality. Okay. So I powered on our Windows 10 too, and it's running on our ESXi 1. Okay. I'm going to restart our ESXi host. I'm going to restart our ESXi host. So power reboot. Test H. Let's check what about the machine. So it is still showing on the ESXi 1. So first of all, vSphere detect the failover, then start this machine on secondary host on your ESXi 2. So look there, Windows 10 2 is disconnected now. It's showing disconnected.
Yeah.
After a few seconds, it's automatically connected on to the host 2. Yeah, look there. Now it's stable. On which ESXi host? On ESXi 2. Look there, it's starting on ESXi 2.
Yeah.
Okay.
Yeah.
So HA cannot prevent your, it cannot completely prevent your downtime. Okay.
Okay.
You face a few seconds of downtime and you lose your real-time connectivity with that machine.
Okay, because I thought maybe you will not, it will not go down at all.
Yeah. We have other functions to for the 100% prevent the downtime. We will discuss it. So first of all, complete those 3 tasks. 101, 102, 103.
Okay.
Okay, complete.
Oh.
Then we move forward.
Naveen?
Yes. Hello.
This one, task 3.
Yeah.
I can't see that. Share my screen.
1 second. Yeah. Share your screen.
Yeah, I'm on task 3. Recorded task 2. In my task 2, I didn't see any name. What is that? Master name. It was empty.
Sorry. Which one?
See, this one was empty for me.
No, no. Click on triggered issue. Okay. You on task 2. Oh, which task you are doing? 1 second.
Now I am doing task 3. I completed task 2. So task 3, what I need to do in task 3?
In task 3, you manage
What is the
the
master API host?
you create management networks.
Yeah,
Just okay. So start your task 3.
yeah, but where is the master ESXi host?
Yeah, basically check on which host your VM2 is running. Select your VM2.
VM2, this one?
Yeah. So we want to check our host is working. So our cluster is working or not. Select summary. Select summary on top. Check what is the host ESXi1.
Yeah.
So reboot your ESXi1. Like type any like test HA. So this VM10 will be disconnected after a few seconds, and after that it will automatically connect on ESXi2. It will start again on ESXi2. So refresh your browser, refresh your vSphere console. Yeah, refresh it's multiple times in interval of few seconds. Yeah, it's rebooting. It's taking few more seconds. Select your Windows 10 too. Click on summary. Now check on which host this. Yeah, it's move on to. Okay. So like
Yeah.
that your cluster will work. Okay.
Okay. So it's done, which means?
Yeah, it's done.
So task 3 is done.
Yeah. So
Okay.
wait few minutes. Then we start our task 4. Okay. Properly start your ESXi host. So it will take few minutes. Then we start our task 3. Have Benjamin, you done your lab?
Hello, I'm sorry. I'm on it because I got a call, so I'm just finishing.
Okay. So complete your lab.
Yeah, I'm almost. I'm on page 103.
On which task you are?
103. 103. Page 103. Right.
Okay.
Talking about page 103, he said, right click the master ESXi host. That means the one ESXi host no one.
So basically, your Windows 2 is powered on or power off?
Window is powered on.
Powered on. On which
It's
host?
it's powered on host one.
Okay. So now reboot your host one. Right click on your host
Okay.
one and reboot.
That's the
So it
ESXi
will,
host.
oh yeah, ESXi host. So this machine will start on your ESXi 2 after a few seconds.
Oh, okay.
Now my EXXi is giving me error. Insufficient vSphere high
Resource,
availability.
resource, because your one host is in like it's restarting. So you have a single host in your cluster. So why you are getting this issue? When your ESXi one is successfully powered on, this issue will automatically disappear.
Okay.
Okay. It take few minutes, I guess.
Okay.
Okay.
Naveen,
Is it done? Yeah. Is it completed?
where is this resource reservation tab? In when you go
Okay.
monitor. Oh, okay, okay. Sorry, I was checking in EXX. Okay, okay. I saw that.
Okay.
Fine. I was
So,
searching in EFX. We need to
okay.
click compute.
Yeah, look there. So we
Okay.
start our task 4. Okay.
Yeah.
So first of all, look on your screen. Then you start your task 4. So in the task 4, we check the vSphere as a cluster's resource uses. Okay. So you can check your cluster resource uses by selecting your cluster, go to monitor, and here your vSphere HA. You can check like in summary. You can identify who is your masters, how many slaves, how many protected virtual machines. You can check your resolution here, resource resolution. So here is the CPU resolutions and which machine has how much resolutions. So if you look at the total resolution capacity is approx 12.65 gigahertz. Use resolution is 6.3. Available resolution is 6.33. Similarly, you can identify your memory resolution and storage resolution. Okay. And in task 5, we manage our slot size. Okay. So it's important to manage your resource with the help of admission control. So in this lab, I'm going to control our admissions. So right click on your cluster, click on setting, select vSphere availability, click edit. And here you find admission control. This one, the fourth one, admission control. So in the admission control is a policy used by the vSphere HA to ensure the failover capacity within a cluster, increase the values of the host failover cluster tolerance, will increase the availability constraints and capacity resolved. So we have some scenarios like host failover and cluster tolerance. So one maximum is one less number of the hosts. So your cluster can like uh, provide the tolerance for one host failure. Okay. Then there is the define the host failover capacity. By how can you define the capacity for failover when your host goes fail? So there are some scenarios like the host cluster percentage. So you can by default is 50%. You can also change this value by overriding. You can define by slot policy. So you can define fixed size slot or you can calculate the slot according to your resolutions and utilization. And you can define the dedicated failover host or you can specify a dedicated host to handle the failovers. Okay. So according to lab, we are going to select the slot policy. So we are going to create create the slots and calculate the slots that are used by the virtual machines to mm, provide the reservations and provide the assigned resources. So first is covered all power all virtual machine. So in this, it's calculate the slot size based on the maximum CPU and memory resolution and overhead of all powered on virtual machines. So only powered on virtual machines will be count in this one. Okay. Let's try to calculate. So it's saying the VM requiring the multiple slots, 0 out of 2. Okay. So I just select covered all, this one. Okay. I'm going to power on the Windows 10 4. Let's check the slot size and other things. So select your cluster, go to monitor. vSphere HA, summary, and scroll down. So look at your slot size is 32 megabytes for CPU and 31 MB for memory. So the total slots in your cluster is 315. Used slots is 2 and available slots is 154 and 159 is reserved. So 50% slots is reserved for failover and 50% slots are available. So out of 50% slots, 2 slots are used by virtual machines. So total power on virtual machine 2, total host in cluster 2, total good host in cluster 2. Okay. So 2 slots are used by your virtual machines. Okay. If we increase the resolution, let's suppose I'm going to assign some resolution on Windows 10 4. So I'm going to assign the CPU resolution like 512 megahertz. Okay.
Yeah.
Now if we check the slot size and use slots, so look there. Now your CPU slot size is 512 megahertz and total slots is now 24. Okay. So and covered all powered on virtual machines option, the slot size will be maximum amount of resolution on a single machine. Okay. So it's calculate you have total 24 slots for CPU and out of 24 2 slots is used by 2 virtual machines and 10 slots are available and 12 slots are reserved for failover. Okay. If we let's suppose I'm going to change our slots admission control again. Now at this time I'm going to configure fixed slot size. So here fixed slot size and let's define the slot size is 300 megahertz. Okay, calculate. So it's saying the one machine using 2 slot. If you click here view, you can find that the Windows 10 4 is using the 2 slots because Windows 10 4 so resolution is 512 MB and our slot size is 300. So this machine, a single slot cannot complete the requirement of this machine. This machine required at least 2 slots to fulfill the resolution. Okay, close. Okay, and if you check here, now you have total slot is 42. 3 slot is used. We have 2 powered on virtual machines and use slot is 3. If I put some resolution on, let's suppose I put the resolution on Windows 10 3. Like I'm just put 310 megahertz. So our slot size is 300. So it also consume the 3 slots because the resolution is more than 300. Okay. So look there. Now use slot is 4. If I provide the resolution more than 600 of this machine, so it will consume more than 2 slot. Like I put 710. Our slot size is fixed for 300, so it use at least 3 slot. Sorry, this machine need 3 slots to fulfill this requirement. So 2 slot used by the Windows 10 4 and 3 slot used by the Windows 10 2. So total slot used by the 5. Okay. And if you go on your admission control, availability, edit, admission control, calculate. Look there, 2 machines using the 2 slots. View. So look there, 10.4 require the 2 slots and 10.2 require the 3 slots. Okay.
Mm.
So remove the vSphere as a slot size in the setting, admission control, cover all powered on virtual machines. Okay. And I'm going to remove the SIP reservation. Task 6, configure vSphere HA cluster with strict admission control. So in this, verify the shutdown operation wait. We shut down our all virtual machine. Okay. Then we assign the 2000 memory or Windows 10 to. Repeat the same task for 3 and 4. Then monitor our status for the memory. Sorry. Edit setting. Memory will be 2000. Do the same setting for other virtual machines. So we cannot change the memory of this machine, so we need to power off this machine. Oh, we need to assign the reservation. Assign the 2000 MB memory reservation to Windows 10 to setting in the reservation tab. Okay. We need to assign the reservation of 2000 to each machine. power on, and power on. Yeah, I'm not able to power on this machine. Look there.
Okay.
I try to power on, I'm getting error.
Failed.
Why? Let's check the ratios. So monitor ratios resolution. So look there, use resolution is memory. The total capacity is 9.5 GB. Use resolution is 7.95 GB. Available resolution is 1.60 GB. But this machine required 2000 MB, means approx 2 GB for the resolution. So you cannot power on this machine. Okay. If you check here, the total slots in your cluster is 4. 2 for availability and 2 for failover. And the 2 slots are used by your 2 machines. You cannot use more than 2. Okay. So if you powered off any one of these machines, then you can power on your another machine. Can I power on this machine now? Yeah. Now you can power on this machine. Okay. So preparation for next lab. Remove the memory resolution. Remove lab server. So let's first start the resolution. Remove this lab server folder. Remove from inventory. Added the setting and administration capacity disabled, and disable your hello capacity. Okay. Complete this lab. Then we start our theory.
Okay.
Hello.
Yeah, Naveen.
Hello. Yeah, it's completed.
Yep.
No, for me, I have not.
Benjamin.
No, page 106.
Sorry.
No, I have not. Page 106.
106. Okay. Okay, Mangesh, let's take a break of 20 minutes. Okay, then we'll continue.
Okay. Yeah.
Okay. So we'll meet at 4:30.
Okay, okay.
Benjamin, complete your lab first. Okay.
Yeah, I'm completing. Yeah.
Okay. Hello.
Yeah, hello.
Hello, Magesh.
This is Benjamin.
Hello, Magesh. Are you there? Magesh, are you there?
Yep.
Okay. So let us start our next chapter. Next lesson is fault tolerance. Okay.
Okay.
So in this chapter, we discuss the benefit of using the fault tolerance, explain how fault tolerance work, describe the main vSphere fault tolerance features, fault tolerance with HA and DRS, and fault tolerance from vSphere web client. So basically, the fault tolerance provides the intensious failover and continuous availability, zero downtime, zero data loss, even no loss of TCP connections. Okay, so in vSphere, we look there, we got some seconds of downtime, but in vSphere fault tolerance, there is zero downtime, zero data loss, and even no loss of the TCP connection. So in the fault tolerance, a exact same copy of your machine will be created on another host. You can say secondary copy of your virtual machine will be created on the secondary host, and both machines will be synchronized. So when you like perform some activities on your virtual machines, so those updates will be synchronized with your secondary virtual machine. Okay, so choose the fast check pointing. So fault tolerance protect the mission critical high performance applications regard of the operating system use, and fault tolerance support the VMs configured with up to the 8 CPUs and 128 GB memory. So your virtual machine's maximum configuration will be 8 virtual CPU and 128 GB memory, and support up to the 4 fault tolerance VM per host with no more than 8 virtual CPUs between them, and vSphere vMotion migration for your primary and secondary virtual machines. Create a secondary copy of all VM files and disks, and provide the fast checkpointing copying to keep your primary and secondary CPU synchronized, and support multiple VM disk formats like thin provisioning, thick with agar zeros, lazy zero, and can be used with vSphere DRS only with enhanced vMotion compatibility mode, and support the interoperability with vSAN. So fault tolerance work with vSphere and vSphere HA and DRS. So with vSphere HA is required for vSphere fault tolerance, restart the failed VMs, and is vSphere fault tolerance away. For the DRS, select which host run the primary and which one run the secondary. So when VM is powered on, and do not automatically migrate the fault tolerant VM. So you need, if you want to migrate your fault tolerant protected VMs, so you need to move those VMs manually. Redundant disks. So vSphere fault tolerant create two complete virtual machines. Each machine has its own configuration files on virtual disks. or those files can be on the same data store or can be a different data store. There is no like this type of dependency. Change on one primary machines are not proceed on secondary machine. Just memory is up to date on the secondary machine. So let's suppose you execute a task. That task will execute on primary, not on the secondary machine. The secondary machine's memory will be updates. Task will not execute on that machine. Memory will be updated to the fault tolerance network. Pre-copies. So using the vSphere fault tolerance, a second VM is created on the secondary host, and the memory of the secondary virtual machine is then copied to the secondary host through the fault tolerance network. Okay. So when you're performing the change on your virtual machines, you are executing some tasks. So those changes will be updated in the bitmaps, and those bitmaps will be transferred to your secondary machine through the fault tolerant network. Fast checkpoint. So symmetric multiprocessor with fault tolerant checkpoint interval is dynamic, and it adopts the maximize the workload and performance of your machines. SAID files. So vSphere fault tolerance has the SAID file. So there is two SAID files. One is SAID.vmft. So this file is accessible by both primary and secondary machines, and this file is used to prevent the UUID change. And another file is .ft generation. It is used for the split brain condition. So split brain condition is like that a process or a file is accessible by the two machines. Uh, Both machines are try to perform the same tasks. So the split brain conditions occur when a host become isolated or paranoid from the master, and the master host cannot communicate with it. It's using heartbeat data store. So in this situation, master host cannot determine the host is alive, so declare as dead. And the master host try to restart the VM that are running on the isolated host or paranoid host. So this attempt success, and if the virtual machine is remain running on the isolated or paranoid host, and the isolated or paranoid host lost the access to the virtual machine data store when it become isolated. So brain split condition exists because the two instances of your virtual machine exist there. Okay, so FT generation file ensure that only one instance of virtual machine can read from or write to the virtual machine disk files. And VMFT is used to prevent the virtual machine UUID change. To enable the vSphere, you need to just first of all establish your fault tolerance network. Then right click on your virtual machine, select the fault tolerance and turn on the fault tolerance. So it will create a secondary VM on another host server. Okay. So in this lesson, we do not have any labs. So I will show how to configure the fault tolerance on vSphere. So let's check. So here I'm going to configure a fault tolerance network. Okay. So I'm just modifying our existing VM kernel adapters. So I'm selecting this vMotion, right click, edit, and I'm enabling the fault tolerance on this one. Okay, fault tolerance. Okay. Perform the same action on the another host. vMotion, right click, fault tolerance. So let's check our Windows 10 2 is running on ESXi 2. Okay, I want to protect this machine through the fault tolerance. So right click on this machine and select fault tolerance. Turn on fault tolerance. So select your data store where you want to create your fault tolerant VM. I want to create the fault tolerant VM on let's suppose this ISKG data store. Next, select your host. So ESXi1. So this is your slab host. So there is some issues like the operation, data store ISKG is being used for the both and primary, and it's saying the operation is not support on one object. The disk 00 is not moving. So any transparent request will cannot be honored. Okay, next. These are some warnings. Finish. Okay. So if we check a fault tolerance, states changed. So if we check in our clusters and the available VMs, so look there, Windows 10 2 is two time here. One is the secondary VM, one is the primary VM. The primary VM is on your host server. Let's enable the host here. Hide and show columns to the host. So look there, your primary VM is on ESXi 1 and the secondary VM is on ESXi, sorry, primary in ESXi 2 and secondary on the ESXi 1. And it takes few minutes to completely create that machine. Okay, it's creating a fault tolerant secondary VM. So like that, you can enable the fault tolerance. Okay. So it will take few minutes. Okay. So after completion, we test this fault tolerance. Okay. So let's discuss our next lesson, vSphere application. So it's a theoretical chapter in this module. And in this chapter, we discuss the vSphere application, configure the vSphere application, recover the replicated virtual machines, identify the benefits of offloaded backup process, and change block tracking. So basically, vSphere application is an extension for your vCenter. You can enable the vSphere application extension on your vCenter server. So it provides a hypervisor-based virtual machine replication and recovery. So need to deploy a vSphere application appliance, and you can integrate that appliance with your vCenter. So vSphere replication appliance provide all the components required to perform the vSphere application. Like it's deployed through the OVF virtual appliance, delivered with vSphere platform, and included with most of vSphere additions. Functionality. So vSphere application enable the replication of VMs from a source site to target site. So you have two sites. Let's suppose one in Delhi, one in Mumbai. Okay. So you can enable the replication between them. From source site to target site, monitor and manage your application status and recovering the VMs at target sites. So you can make a copy, make a replica of your VM there. You can recover your VM from your target site. So deploy the virtual appliance, go to your vCenter server, select host and cluster, right click and select deploy OVF template. Then you can go to the actions or select all vSphere application actions and configure your application. Then you can define your replication objectives, like how many instances per day you want to replicate or recover. You can define your virtual machine, which virtual machines you want to like protect for replication and recovery. You can use the APIs to protect your data protections. You can use the offloading backup data process to write your virtual machine backups on the disk, on the tapes with the backup server. About the change block tracking. So with the change block tracking, you can copy only file blocks that have changed in the last backup. Okay, so it's backup those blocks that are changed after last backup. Okay, so change block tracking enable the faster incremental backup. So this is our vSphere HA fault tolerance and data protection chapter. The next chapter is DRS. So we discuss this chapter tomorrow. Okay,
Okay.
the distributed resource scheduler. So let's check. Is it still going? Okay. After completion, if your if on which server Windows 2 is running, so our primary machine is running on ESXi2. If your ESXi2 goes down, you still able to access your Windows 2 without a second of interruption. Okay, so your secondary VM is provide the response at that time. Okay, Magesh, share your screen. Let complete assessment. Share screen with us. Open your on-demand content. No, 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 no. On-demand content.
Yeah.
Back to chapter number 9. Yeah, get start.
Tools is included.
What are the guidelines to create vSphere HA cluster? A
Yeah,
cluster can host cannot be used DHCP. All hosts must have at least two management network. Only vSphere HA cluster that contains external can enable them.
yeah, last one is correct.
Yeah.
First one is, yeah, right.
Which of the site option does vSphere application support to protect virtual machine from partial or complete site
Partial or
failure?
complete. So within the site from one cluster, and
multiple in
multiple
a
site.
single site.
Yeah, A and B.
In which scenario does vSphere HA try to restart virtual machine? Data CPU heartbeats.
Data store heartbeats. Data store heartbeats. First of all, it's check to the management network. If host is not replying back to the management network, then it's try to communicate with data store. If data store is if the host is not able to communicate through the data store heartbeat, then vSphere HA try to restart that machine. Okay.
Okay. When does the vSphere HA restarts the affected virtual machine on the other host? When it is like when the host falls.
Please.
Right. It's a single choice.
Yeah.
How does a vSphere HA ensure that the primary virtual machine CPU and second is synchronized? By supporting provision or by supporting intervention with SAM. Checkpoint copying.
Okay. Yeah,
And
first
one.
Last one. By supporting the vision interoperability.
What are the advantages of having vSphere fault tolerance work with the vSphere DRS? Prevents the running fault virtual machine and secondary copy on the same host. One and
Select which host in the primary and secondary host virtual machine power on. B. Create two complete virtual machine and prevent the virtual machines.
Next.
Yeah, it's correct.
No.
No. Not C. It's A.
Okay. Which product ensure version during a planned outage? Which is replication?
Not a replication.
vSphere storage vMotion. This is to move the virtual machine, but how it will be available?
vMotion and storage vMotion.
Okay. Identify the scenarios in which the master host determines that the slave host is not responding. No problem. Okay, I think it will be due to
Firewall.
hardware. Firewall. One is component.
Yeah.
Okay. Cool.
Okay.
Cool.
So this is our HA chapter. In next module, we discuss about the DRS. Okay.
Okay.
Cool. Sure.
Mm.
Thank you, Naveen.
You're welcome.
Okay. Thank you. Have a nice evening.
Yeah.
Thank you, Ben. Bye.
Okay.
Bye.
Bye.